Hello, everyone. So this was number 14 on the 10B. So we have a question where we have like region B, which is dartboard, in the current plane such that the absolute value of the x and y is lesser than or equal to 8. And then there's a target region T where that will satisfy this inequality. And then we want to find the probability that the dart will be landing in that region T out of that region B. Okay, so this is actually not too challenging, and I've seen a lot of similar questions in the past years, which I'll attach in the description as soon as I can. So, but that will be one of the cases we have. So, like if you want to like graph the absolute value, so just take some the endpoints or boundaries, and let's say if you choose x is 0, right? So if I choose x is 0, then this will be gone. So the absolute value of y will be less than or equal to 8. So you can just say y is less than 8. Or actually, I should write this a bit first. So the absolute value of y is lesser than or equal to 8. But when this is the case, y would be anything between 8 and -8, right? So that should be at most 8 and then at least -8. So let's try to graph them. And then since this is symmetric, I'm going to just make the entire region. So we have y is at most large, like -8, and at most +8 and -8. So let's say this is -8, and let's say this is a +8. And if you do the other way around, so if I choose y is 0, right, then you do get same thing with the x instead. So let's say this is 8. So the x would be in between 8 and -8 if I choose y is 0. So that should be right here, and that should be right there. Okay, so we got this. Like, if you don't really see now what's gonna happen, like you can just maybe say, like, choose a number, right? Say if I choose x is 4, just plug it right here if x is 4. So then the equation become like absolute value lesser than or equal to like 8, but that was 4, so 4 plus that should be less than or equal to 8. So that means y has to be less than or equal to 4. So which means we have two values, which is 4 and -4. So you can kind of see that will be a straight line. And also, when you take the one of these values, like if you choose like another way of saying, basically, if I make x and y is both positive, you get x plus y is less than or equal to 8. So this is a straight line. So that means you're going to connect these basically points. So that would be another way to look at it. Anyway, so that is going to be a square with this side length of x root 2, because the length is 8 units. So that should be 8 root 2. Okay. And that is okay. So now we have, this is the region B, right? This is B. And we'd like to find the T as well. So this is kind of a square is not nicer. So I'll take the square root out both sides. But when I do that, like kind of using a similar idea, like when this y is lesser than or equal to 8 in absolute value, when you remove the absolute value, you can say that's also larger than -8. So a negative version of this. So the same thing going on here. So when you square some stuff to get at most 49, the whatever you square could be at most 7, but it could be all the way -7 as well. So I'm going to just say -7 all the way x squared plus y squared minus 25. That is lesser than 49, but that's just going to be square rooted, so which is just going to be 7. Now add 25 to both like side of inequality. So you got 16 is x squared plus y squared, and that will be 32. If I take this only, that means x squared plus y squared is larger than 16, or, oh, this was 4 squared, right? So let me double check. Okay, 25. Yeah, I think that's 18, actually, not 16. 18, yeah, this should be 18. So if you take the square root, so that could be written like 3 root 2 to the second power. The reason I just write this way because this is the equation of a circle. It says x squared plus y squared is larger than this. So this is a circle where the center is 0, 0 with the radius of 3 root 2. And since it's as larger, which means we are looking for the outside of the region. But if I take the next one, like if I take this part, so that will be x squared plus y squared is lesser than or equal to 32, which can be written as 4 root 2 squared. This is another circle with radius of, with the center of 0, 0, but the radius now 4 root 2. So then 4 root 2 is a good number because if you look at this, this was 8 units, this is 8 units. If you connect all the way to the middle one right here, so this is like 8 units. So this is 4 root 2, this is 4 root 2. So this is also 4 root 2, which means my second circle that I'm trying to find the area inside should be touching exactly at the middle of these sides because those are 4 root 2 units away from the origin. And the corners are more than that, so which is why we are kind of safer with that. So we can just say this is the circle. We are basically finding the area of inside. So, but this is the circle for this one. So this has to be the one that has root 3 root 2 as the radius, so which is smaller than that. So if I say this is 3 root 2, so that should be 3 root 2 and stuff like that. So you have another circle. The smaller one is not that small, but I just did that way. So then what we need is just the region in between. So this is the region is like donut, right? So that would be the region that we are interested. And how do I find it? Like that's the difference of the area of these circles, right? So the larger circle has area of pi times 4 root 2 square, and the smaller one pi times 3 root 2 square. And that's the desired region. Divide by the area of the square outside. So this was 8 root 2, this is 8 root 2. So you can say 8 root 2 times 8 root 2. And that will be 32 minus 18, which would be 16, right? So 16 pi over. So this is 8 times 2. Let me double check. So that looks like we have this way, right? So 32 over 2, that's good. So that's 18. That's 14. Okay, so if I divide by 2, these will cancel. You got 7. So the answer looks like 7 pi over 64. And we are told that's written in something over something times pi, so which is 7 and 64. So if you add those, you got 71. So again, this wasn't too challenging. So I guess it's just another inequality problem with the absolute value as well as the circle. So anyway, I'll see you in the next week.